let's talk about something wild. We all think we know what a computer is, right? It's the laptop I'm looking at, the phone in your pocket. But what if I told you that computation, it's more like a ghost? It's hiding in the machinery of things you would never expect, just waiting for someone to find it.
I mean, here's a question for you. Could you build a fully functional computer using a fantasy card game? One with wizards and monsters, not circuits and code. Sounds absolutely ridiculous, doesn't it?
Well, the crazy thing is, the answer is a resounding yes. A few years back, researchers proved that the rules of the card game Magic: The Gathering are so ridiculously complex that you can arrange them to perform any computation imaginable. And that's just the tip of a very, very strange iceberg.
And get this, it gets even weirder. A normal computer processor has hundreds of different commands it can run. But some programmers proved you only really need one. Just one. The move instruction, which literally just moves data from one place to another. They even managed to get the video game Doom to run using only that command. Now, it was painfully slow. We're talking one frame every 7 hours. But it proves the point. Incredibly powerful computation can emerge from the absolute simplest parts.
So this all forces us to back up and ask a pretty huge question. If a card game can be a computer, if a single instruction can be a computer, then what does the word computer even mean anymore? To get our answer, we actually have to go all the way back to the 1930s and the legendary Alan Turing. He came up with this idea called Turing Completeness. Basically, any system, any set of rules, is Turing complete if it can be used to simulate any other computer. It means the system has hit this kind of universal threshold for computational power.
And that leads to an even more mind-bending idea, Turing equivalence. If two computers can perfectly simulate each other, then for all intents and purposes, they're the same. They're computationally equal. Just think about that for a second. It means that on a deep, fundamental level, your gaming console, a PowerPoint presentation, and that deck of Magic cards are all equally powerful. They can all emulate each other.
Now, you'd think achieving this kind of universal power would be super difficult, right? Something that has to be carefully engineered. But it turns out it's the exact opposite. It's actually really hard to create any complex system of rules that doesn't accidentally stumble into becoming a universal computer.
So if this stuff is everywhere, where exactly are we finding it? Well, it pops up in the most bizarre places imaginable. Let's do a quick tour through this universe of weird machines. Just look at video games. It's absolutely rampant. Players in Minecraft use the game's basic redstone blocks to build gigantic working processors. And even crazier, a glitch in the original Pokémon Yellow lets players write and execute their own programs just by buying items from a shop in a very specific order.
It's not just in software. It's happening in the very tools we use to build it. Features in programming languages like C++ and TypeScript, things that were only meant for organizing code, turned out to be fully functional programming languages themselves by complete accident. And you don't have to be a coder to see this. You probably have one of these accidental computers on your own machine. Seriously, it's been proven that you can build a universal computer using only PowerPoint animations. No coding, just shapes and transitions, with the user clicking the mouse to act as the computer's clock.
Okay, let's stop for a second. This is the part where it starts to feel like actual magic, right? How on earth can these systems with such basic, limited rules suddenly become so incredibly powerful?
A perfect way to wrap your head around this is something called Conway's Game of Life. All it has are a few simple rules about cells on a grid turning on or off based on their neighbors. But from those tiny rules, incredibly complex patterns emerge. Patterns that can be combined to create logic gates, memory, everything you need to simulate any computer in existence. And it turns out there's a kind of recipe for this. All these accidental systems stumble upon the same 3 basic ingredients. First, they need a way to store information, which we call state. Second, they need rules to change that information. And third, they need a way to do it over and over, repetition. Think about that PowerPoint computer. The shapes on the slide are the state, the animation logic provides the rules, and you clicking the mouse over and over provides the repetition. Once you have those 3 things, boom, you have a computer.
Now, this is all fascinating as a thought experiment, but it's also got a really dark side. As a couple of security researchers famously put it, we like to pretend our software is simple and predictable. But the reality is, our programs are often built on and contain these other, much more bizarre computers. And yeah, In the cybersecurity world, they've got a name for this. They call these hidden computational systems weird machines. And trust me, they're not just some quirky academic idea. Weird machines represent a massive blind spot in how we think about security, and they are incredibly dangerous. And attackers? Oh, they have absolutely learned how to program them. They've weaponized the most obscure parts of our computers, turning CPU memory errors, that move instruction we talked about, even the system that just draws letters on your screen, into tiny, secret computers to launch attacks. So here's the core threat. If a simple data file, like an image, is secretly a computer, an attacker can literally write a malicious program and disguise it as data. That program then runs inside what's supposed to be a safe little box, sneaking right past all the security we build.
And please, don't think this is just theoretical. It has happened. A famous real-world hack used the logic of an image compression format, a system for making pictures smaller, to build a custom computer inside an image file. They then used it to break into the phones of political dissidents. And to give you a sense of how complex this was, the attackers used over 70,000 individual commands to build and run their tiny computer inside that picture. This wasn't a simple trick. It was a full-blown engineering project running on a computer that wasn't ever supposed to exist. Which really brings us to the whole point of this. We have this idea that computation is an act of creation, right? Something that we humans design and build on purpose. But maybe the truth is way bigger and way stranger than that. It seems that computation isn't something we invent at all. It might just be a fundamental emergent property of the universe, like gravity. It's a ghost in the machine of any system that gets complicated enough. We don't build it, we just discover it. And that's the thought I want to leave you with. If this universal, powerful ability to compute is just hiding there in everything from card games to image files, what other fundamental truths about our world are hiding in plain sight, just waiting for us to accidentally stumble upon them?